Welcome to Homework Lib.
We have the following expression for the entropy as a function of n and n prime, and we want to evaluate this partial derivative over here. So in order to do so, what we're going to employ is a lot of Stirling's approximation. So remember that the Stirling approximation tells us that logarithm of n factorial is going to be equal to n logarithm of n minus n. So the first step is going to be to re-express our entropy as something that is a little bit nicer. So in this case, we are going to do all of the steps along the way. First of all, the product inside of a logarithm, you can write it down as a sum of the logarithms. The next step is going to be the division. We're going to be able to write down as a subtraction. So the next step over here, we're going to get logarithm of n factorial minus logarithm of n factorial minus logarithm of n minus n factorial plus logarithm of n prime factorial. I'm going to continue down here, minus logarithm of n factorial minus logarithm of n prime minus n factorial. So we can reduce this a little bit. Notice that we're going to have 2 times logarithm of n and n prime. And this is going to be equal to k times the logarithm of n prime minus 2 logarithm of small n prime plus logarithm of n prime factorial minus logarithm of n minus n factorial. Let me put it with this factor over here, and minus the logarithm of n prime minus n factorial. So now with this, when we take the partial derivative of s with respect to n at constant n and n prime, this is going to become minus 2 times k, the partial derivative of the logarithm of n factorial with respect to n, minus k times the partial derivative of the logarithm of n minus n factorial with respect to n, and minus the same contribution but now with a prime in front of it. Let me put it down here just to take advantage of the space. Minus k times the partial derivative with respect to n of this factor, n prime minus n factorial. As you're going to notice, all of the other factors are not going to depend on a small n, so we can discard them directly. Now we're going to apply Stirling approximations. So this will be minus 2k. The first factor is going to be the partial derivative with respect to n of logarithm of n factorial is equal to n logarithm of n minus n minus k times the partial derivative with respect to n of n minus n times the logarithm of n minus n minus n minus n. And finally, a factor that is going to look exactly the same, but with n primes. N prime minus n, that's going to multiply logarithm of n prime minus n minus n prime minus n. All of this in parentheses. So now we can proceed with doing the derivatives on each of the cases. The first factor is going to be minus 2k. the partial derivative of n logarithm of n is going to be logarithm of n, oops, plus n times 1 over n, so this is going to be a 1, minus 1. So 1 minus 1, this is going to be a 0. Now the next factor is going to be minus k, the derivative of the first factor with respect to n, that is going to be minus 1, minus 1 times logarithm of n minus n, plus n minus n divided by n minus n. Sorry, divided by minus n minus n. Actually, let's make it more direct. Just to plus n minus n multiplied by minus 1 over n minus n. Minus 1, which is going to be plus 1 over here, the last derivative. And the next factor is going to look exactly the same, but with n prime. So minus k minus logarithm of n prime minus n plus n prime minus n multiplying minus 1 over n prime minus n plus 1. So from all of these factors, this is going to be equal to minus 1. Minus 1 plus 1 is going to be equal to 0. And over here as well, this is going to be minus 1. Minus 1 plus 1 is going to be equal to 0. So the result that we're going to find is minus 2k times logarithm of n plus k logarithm of n minus n plus k times logarithm of n prime minus n. We can factorize the k out of everything, and this is going to be k times 2 logarithm of n plus logarithm of n minus n plus logarithm of n prime minus n. And this is going to be the partial derivative of s with respect to n at n and n prime constant.